So far we learned LLMs take a sequence of words as the input sequence and predict the next token, right? And also LLMs have emergent properties, and LLMs understand the form, that is grammatical construction and meaning of it, right? Now let's see how was an LLM built. So what do we need as toolkits? The first one is data, and the second one is model, and the next step is fine tuning the LLM on the labeled data. The first thing is data, right? So we need data. So they gathered a huge amount of data from the internet, be it text or books or media or research articles, whatever the data that is publicly available. They gathered the data. So this is the raw unlabeled text. So let me show you an example of the data they used to train the model, right? For example, if you see here, this is the data they used to train a GPT-2 model. And if you see here, dataset name, dataset description, number of tokens they used, and proportion in training data, right? Like I said, they have gathered the data from different data sets. And if you see here, common crawl, so this is the data that consists of large aggregated data from different websites, right? So let me take you there. Okay, so you can see common crawl maintains a free open repository of web crawl data that can be used by anyone, right? And similar to common crawl, we also have open web text corpus, right? So this is another website where you can get the data from. Okay, so similarly, web text to books, Wikipedia, right? So they have gathered the data from different websites. That is the step number 1. So they gather the data from numerous websites. That is the first step when building an LLM, that is train on a large corpus of text data, that is raw text. Raw text means regular text without any labeling information on that. So this is the first step in building an LLM. And the next step is model pre-training. Okay. So once we have collected the data, the next step is to build the model. The foundation model is built on top of the transformer architecture. So we train this model with a huge amount of data, and this is called foundation model or pre-trained LLM. We haven't fine-tuned this model yet. So the first training stage of an LLM is also called pre-training. That is creating an initial pre-trained LLM, that is base or foundation model. For example, GPT, right? So the model is a pre-trained model which is capable of text completion, that is predicting the next word, right? And fine-tuning the LLM on a labeled data. So we take the labeled data to perform various tasks like text translation or summarization or classification, right? Or personal assistant. That is, we provide the input as well as the output label data. That is, what is the input and what should be the output. So if this is the input, this should be the output, and if this is the input, this should be the output, right? So that is the labeled data. So that is how we fine tune the data. Whereas when we are pre-training the model, it is raw unlabeled data. That is, after obtaining the pre-trained LLM, we can further train an LLM on labeled data. So this is the high level workflow of how LLMs are built. Okay. Just to tell you one more on fine tuning, we have two categories of fine tuning. One is instruction fine tuning and the other one is fine tuning for classification tasks, right? So in case of instruction fine tuning, the labeled dataset consists of instruction, that is answer pairs, right? For example, text translation or airline customer support, right? Whereas with the fine tuning for classification tasks, the label dataset consists of text as well as the associated labels. For example, if you take emails, right? So spam versus no spam, right? So for the classification, also we can use this fine tuning. And when GPT 3.5 came into the market, they did pre-training and as well as fine tuned the model as well. And the total pre-training cost for GPT-3 was $4.6 million. Okay. So this is the workflow of how an LLM has been built. And if you see, nowhere we taught the model on language or meaning, right? That is, the model understood the language by itself because of the numerous amount of data that the model has been trained on. So the model which is pre-trained and fine-tuned serves as the brain to an agent. So this LLM can do various tasks. It can do text summarization or text classification or text translation, right? So we have seen different examples in the previous lectures when we learned what an agent is, right? That is flight booking, etc. So in order to do that, the first thing is the language model needs to understand the language itself. For example, let's say you want to build an LLM which can answer all the questions related to Medicare. Then what do? We collect the data, example Medicare data, and then we tokenize the data, that is passed through the entire transformer architecture. Then we will get the next predicted token. Then we will compare this predicted token with the actual token and we will get the entropy loss. And then we will do the back propagation to minimize the loss. Okay. So this is exactly what happens when I say pre-training an LLM. So don't worry if you don't understand this. And if you want to deep dive into what is ChatGPT and how does it work, I will provide an article. So in this article, they've explained what is ChatGPT and why does it work, right? So you can go through this article as well when you have time. I will provide this in the resource section. Okay. So agents use LLM as their brain. So for that, we need to understand React framework. So let me show that article as well. React framework, synergizing reasoning and acting in language models. Okay, so we will understand how LLMs are integrated with agents, that is how LLMs are equipped with reasoning as well as action, and we will learn this in the next lecture. Okay. So in summary, LLMs are the next token prediction engines, right? So they are probabilistic prediction engines. They will choose the next token based on the highest probability scores. So why do we pre-train an LLM for predicting the next token? Because LLMs learn the form, that is the grammatical correction and meaning of the language. And then we learned that language models are called large language models because they have a huge number of parameters. And why do we need so many parameters? Because we have two reasons, right? Emergent properties and language learning. So emergent properties means accuracy is directly proportional to the number of parameters, and language learning means they need more parameters so they can learn the language effectively, right? And the core of LLM is the transformer architecture, and we also learned the difference between AI, machine learning, deep learning, generative AI and LLM, right? And finally we learned that LLM has two stages, pre-training and fine-tuning. So fine-tuning comes after pre-training, right? So that's all about LLMs, right? So far we learned what is an agent and what is an LLM, right? And in the next lecture, we will deep dive more. All right. Thank you.